Hello. And welcome to Protrain's Certified Cost Professional CCP Preparation course. In this lecture we will talk about earned value management concepts. Let us get started. One of the famous quotes by Peter Drucker, who has been described as the founder of modern management, is, "You can't manage what you don't measure." While this Peter Drucker quote comes from general management background, it is also equally applicable in project management domain. So, what we want to say here by referring to this quote. In order to have a successful project, which means on schedule and within budget project delivery, we need to measure the project performance throughout its life cycle. This is where earned value management comes into the picture. Earned value management is a project management technique for measuring the project performance. Now, when we know the background why we need earned value management, let us look at what we are going to learn in this lecture. In this lecture we shall learn overview of earned value management, basic elements of earned value management, tracking project performance using earned value management, earned value forecasting approaches, implementing earned value system. Here we shall briefly review ANSI, EIA 748B standard. Let us take deep dive and understand why we need earned value management, and how earned value management can help us measuring and managing project in a better way. This is Sophie. She is project manager of a high-rise building project. Two of her major responsibilities are to deliver project within budget and to complete project on schedule. In her role as a project manager, she is surrounded by thousands of questions on project performance like: how much money we have spent till date? Is project still within the budget? If it not on budget, how much is budget overrun? Can we recover from current budget overrun? How much we need to spend more to complete the project? Is project on schedule? If not on schedule, how much we are behind? If project scope is managed effectively. This is the place where earned value management or EVM comes to help us. Earned value management is a project management technique for measuring project performance and progress in an objective manner. Before we get into details of earned value management, let us understand advantages of earned value management over traditional cost-based project control system. Let us have a look on the screen. Here we shall take example of a simple task of pump manufacturing to compare between traditional cost-based control system and earned value management. On the x-axis we have time. Here we have divided the project duration of 1 year into 4 quarters. Quarter 1 to Quarter 4. On the y-axis we have cost. We are showing cost in multiple of $1,000. On the x-axis on top above we are showing the units planned for manufacturing. The pump manufacturer is planning to manufacture 250 units at the end of first quarter, and cumulatively 500 units for the second quarter, and so on. At the end of the year 1,000 units are planned for the whole year. Please note that all the unit manufacturing shown here are cumulative. In other words, It also includes the production of previous periods. If the cost of a unit is $1,000, the curve shown on the slide shall represent the spend plan for the manufacturing facility. Now assume that the project is under execution. We are at the end of second quarter. Actual cost is now drawn on the slide. If we observe the cost performance and the end of second quarter, we shall find that the planned spending was $500,000, and the actual cost is again $500,000. So, what does it mean? Everything is good, as our planned spending and actual cost is the same. What we planned, we have achieved the same. So, does it mean everything is good? Is it the scenario? No, it may not be. Sometimes traditional cost-based controls systems may not show the actual project status. We will see how it is possible in a moment. Now we are showing the actual unit produced for quarter 1 and 2. To our surprise, manufacturing facility produced only half of the units those were planned during the periods. However, they spend all the money which was planned. Essentially, the traditional project cost management is not able to report, or identify project issues holistically. This is where earned value comes in as a tool to provide clear picture of the project status. How earned value shall help us to tackle this issue? Let us learn now. Line on the slide shows earned value at the end of second quarter. While we shall understand earned value in detail in a moment. However, in order to continue the discussion, let's quickly understand what is earned value. Earned value is budgeted cost of work performed. So what shall be earned value at the end of second quarter? The budgeted cost was $1,000 per unit, and 250 units were actually produced. Therefore, earned value shall be 1,000 multiplied by 250, which is equal to $250,000. So, this establishes that there is something wrong in traditional cost-based management. In the next slide we will understand how to measure the variances. Based on earned value we identified in the last slide, let's compare the traditional cost management approach to the earned value management approach. In the traditional cost management approach we compared the planned spending and actual cost. Both were same, $500,000. Following the cost management approach, variance from plan expenditure was 0, therefore project was fine. Now let's go to earned value management approach. In the earned value management approach we also calculate earned value along with planned value and actual costs, and compare earned value with planned value and actual cost. In this example we are finding that earned value has negative variance of $250,000 from both the planned value and actual costs. This means that project is not performing as planned both in the terms of cost and schedule. These findings are contrary to the traditional cost management approach findings. So how earned value is able to identify this? This is because earned value not only compares the actual cost against its baseline budget, but also integrates time and scope, while making the comparison between planned and actuals. Overview of earned value management. Earned value management, EVM, is a project performance management technique that objectively tracks physical accomplishment of work. Now the question arises, what is performance management? Performance management is the integrating process of planning, managing, and controlling project performance. Measures of progress should be articulated in terms of cost, schedule, and scope. EVM includes techniques and metrics for expressing and evaluating progress against cost, schedule and scope baselines of a project. More elaborately, EVM is integrated project management. It is the management tool that integrates work scope with schedule and budget. EVM requires that a performance management baseline is established. It is essentially a baseline schedule and budget. Work progress is measured as earned value, a yardstick. EVM help us track the progress and status of a project and forecast the likely future performance of the project. In other words, EVM technique can be used to show past performance of the project, current performance of the project, and predict the future performance of the project by use of mathematical techniques. Schedule and cost variances are isolated and reported to the project manager for corrective action. Earned Value Management System, EVMS, is a systematic approach to implement earned value management across the enterprise. EVMS not a specific system or tool set, but rather, a set of guidelines that guide a company's management control system. EVMS best business practices are documented in ANSI/AS Standard 748-98. EVM emerged as a financial analysis specialty in United States government programs in the 1960s, but it has since become a significant branch of project management. EVM allows projects to be managed better, on time, on budget. Good planning coupled with effective use of the EVM technique will reduce a large amount of issues arising out of schedule and cost overruns. If you are completely new to earned value management and find it difficult to comprehend couple of points we just now discussed, no worries, just keep note of them. You shall get complete understanding of EVM as we shall progress through this lecture. There are following three basic elements of EVM. Planned value, PV. Actual cost, AC. Earned value, EV. All the three elements must be captured on a regular basis as of a reporting date. Let us discuss each element in detail now. The first EVM element is planned value, PV. This is also referred to as budgeted cost of work scheduled, BCWS. Planned value, PV, or BCWS is the total cost of the work scheduled or planned as of a specific or reporting date. The total PV of a task is equal to the task's budget at completion, BAC, or the total amount budgeted for the task. This is calculated as PV, or BCWS equals planned/scheduled task units, multiplied by planned cost per unit of the task. PV, or BCWS equals total hours planned or scheduled, multiplied by hourly rate. Please note that unit of measurement of PV, EV, and AC can be either cost of task, or man-hours. We shall find both dollar or man-hours based problem in the exam. Earned value, EV. This is also referred to as budgeted cost of work performed, BCWP. Earned value, EV, or BCWP is the total cost of the work completed or performed as of a reporting date. This is calculated as EV, or BCWP equals actual task units completed, multiplied by planned cost per unit of the task. EV, or BCWP equals baseline cost, multiplied by % complete actual. Actual cost, AC. The costs actually incurred for the work completed by the specified date. This is also referred to as actual cost of work performed, ACWP. Actual cost, AC, or ACWP is the total cost taken to complete the work as of a reporting date. AC is used to answer the question, how much have we spent on the project as of today? This is calculated as AC, or ACWP equals hourly rate, multiplied by total actual hours spent, where $ are unit of the measurement. AC, or ACWP equals actual money or hours spent till date, where hours or $ are unit of the measurement respectively. All these three elements can be derived from work breakdown structure by associating the costs to each of the tasks. For big projects, it will be a tedious task to calculate these elements manually. Scheduling software like Microsoft Project and Primavera, and sometimes other custom-built software, can be used to calculate these three elements. If you have observed carefully, we have used two terms, % complete planned and % complete actual in the planned value and actual values formulas. Let us understand these terms. % completed planned is the percentage of work which was planned to be completed by the reporting date. This is calculated using the following formula. % completed planned equals planned value, PV, divided by budget at completion, BAC. % completed actual is the percentage of work which was actually completed by the reporting date. This is calculated by using the following formula. % completed actual equals actual cost, AC, divided by estimate at completion, EAC. Okay, I understand what you are thinking of. Budget at completion, BAC, and estimate at completion, EAC, may be new to you. Wait for a moment, take note of it. We will discuss these two terms in a while. Measuring cost performance. Until now we have discussed about various earned value terminologies. Now let's discuss how we can use earned value management to measure project performance. At first, we shall discuss project cost performance, and thereafter we shall discuss project schedule performance. Let us start with cost variance. Cost variance, CV, is an important factor to measure project cost performance. It indicates how much over or under budget the project is. Cost variance can be calculated as using the following formula. Cost variance, CV, equals earned value, EV, minus actual cost, AC. Or cost variance, CV, equals BCWP, minus ACWP. The formula mentioned above gives the variance in terms of cost. CV indicates how less or more cost has been spent to complete the work as of date. Positive cost variance indicates the project is under budget. Negative cost variance indicates the project is over budget. Cost Performance Index, CPI. Cost Performance Index or CPI is an indicator showing the efficiency of the utilization of the resources on the project. CPI can be calculated using the following formula. CPI equals earned value, EV, divided by actual cost, AC. Or CPI equals BCWP divided by ACWP. The formula mentioned above gives the efficiency of the utilization of the resources allocated to the project. CPI value above 1 indicates efficiency in utilizing the resources allocated to the project is good. CPI value below 1 indicates efficiency in utilizing the resources allocated to the project is not good. To complete Cost Performance Indicator, TCPI. To complete Cost Performance Indicator is an index showing the efficiency at which the resources on the project should be utilized for the remainder of the project. This can be calculated using the following formula. TCPI equals BAC minus EV divided by BAC minus AC. Or TCPI equals BAC minus BCWP divided by BAC minus ACWP. If the project goes over budget, BAC shall be replaced by estimate at completion, EAC. We shall discuss EAC in a moment. TCPI gives the efficiency at which the project resources should be utilized for the remainder of the project. TCPI value above 1 indicates utilization of the project resources for the remainder of the project can be stringent. TCPI value below 1 indicates utilization of the project resources for the remainder of the project should be lenient. Measuring schedule performance. Now let us talk how we can measure schedule performance using earned value management. The first term is schedule variance. Schedule variance indicates how much ahead or behind schedule the project is. Schedule variance can be calculated as using the following formula. Schedule variance, SV, equals earned value, EV, minus planned value, PV. Or schedule variance, SV, equals BCWP, minus BCWS. SV formula gives the variance in terms of cost. This indicates how much cost of the work is yet to be completed as per schedule, or how much cost of work has been completed over and above the scheduled cost. Positive schedule variance indicates we are ahead of schedule. Negative schedule variance indicates we are behind of schedule. Schedule Performance Indicator, SPI. Schedule Performance Indicator is an index showing the efficiency of the time utilized on the project. Schedule Performance Indicator can be calculated using the following formula. SPI equals earned value, EV, divided by planned value, PV. Or SPI equals BCWP, divided by BCWS. The formula mentioned above gives the efficiency of the project team in utilizing the time allocated for the project. SPI value above 1 indicates project team is very efficient in utilizing the time allocated to the project. SPI value below 1 indicates project team is less efficient in utilizing the time allocated to the project. To complete Schedule Performance Indicator, TSPI. To complete Schedule Performance Indicator is an index showing the efficiency at which the remaining time on the project should be utilized. This can be calculated using the following formula. TSPI equals BAC minus EV divided by BAC minus PV. Or TSBI equals VAC minus BCWP divided by BAC minus BCWS. The formula mentioned above gives the efficiency at which the project team should utilize the remaining time allocated for the project. TSBI value below 1 indicates project team can be lenient in utilizing the remaining time allocated to the project. TSBI value above 1 indicates project team needs to work harder in utilizing the remaining time allocated to the project. Forecasting using EVM. Until now we learned how earn value can be used to track the project performance as on the date, or up to a specified completion period. Now let us see how we can use earn value to forecast project performance. The first term we shall learn is estimate at completion or EAC. EAC is expected total cost of a task, or the project when the defined scope of work will be completed. EAC is equal to the actual cost of work performed, ACWP, plus the estimate to complete, ETC, for all of the remaining work. Or, EAC equals AC plus ETC. There are 3 ways to calculate EAC. We shall learn them in next slide. Estimate to complete, ETC, is another forecasting tool in project cost management. It is the expected amount of money that you will spend to complete the remaining work. For example, let us say that we have a project and about 30% of project is completed, and 70% is yet to be completed. In this case, estimate to complete, ETC, is the expected amount of money to complete the remaining 70% of work. ETC tells us that from now, how much we may have to spend to complete the project. It is the estimated cost to complete the remaining work. The formula is ETC equals EAC minus AC. Variance at completion. As name suggests, VAC is the cost variance when the project shall complete. Variance at completion, VAC, is the variance on the total budget at the end of the project. In other words, this is the difference between what the project was originally expected, baselined, to cost, versus what it is now expected to cost. Therefore the formula is VAC equals BAC, minus EAC. A negative VAC indicates that the project is over budget. Now let us discuss how we can forecast project cost using earned value. We have 3 basic forecasting approaches. The first is, planned rate shall prevail for remaining works. This approach assumes that work from a particular point forward will progress at planned rates, whether or not those rates have prevailed to this point. The formula is estimate at completion, EAC equals AC plus, BAC, minus EV, or, EAC equals ACWP plus, BAC minus BCWP. Second approach is, till date rate shall prevail for remaining works. This method assumes that the rate of progress prevailing to date will continue to prevail. Estimate at completion, EAC equals, VAC, divided by CPI. This can also be written as EAC equals AC plus, BAC, minus EV, divided by CPI. New bottom-up estimate to complete, ETC. This is third the approach, in which estimate of the remaining works are re-estimated and new estimate to complete or ETC is established. And, estimate at completion, EAC is calculated as AC plus ETC. Estimate to complete data can be the time distributed to develop etc. curve. Additionally, the forecaster can make the best extrapolation possible by using the typical shapes of the curves and whatever other information may be available to make the projection of estimate at completion or EC. Earn value terminologies example. A moment before we have understood terminologies of earned value management. Now let us recap them using a graphical presentation. Let's see what we have on the screen now. On the x-axis we have duration, or time of the project in days. To simplify, we have divided project duration in 4 quarters, first quarter to fourth quarter. On y-axis we have cost or value, which can be represented both in terms of work hours and dollars. First term we learned in earned value management is plan value or PV. Curve now shown on the slide represents planned value. The last point of planned value graph shows the budgeted cost of the project at completion. This is also called the budget at completion or BC. Let us further drill down to plan value. So what is plan value? We learned in an earlier slide that plan value is scheduled task units multiplied by budgeted cost of each unit. It is important to understand that plan value numbers are generated at the planning stage of the project, and eventually become baseline for monitoring the earned value and actual cost. Now let us consider that half of the project duration is elapsed. Point now highlighted show the planned value at the end of the second quarter. Now, based on the current project status updates, let us see what is earned value. The curve shown on the slide represents earned value. So what is earned value? We learned in earlier slides that earned value is actual task units completed, multiplied by budgeted cost of each unit of the task. The end of this curve shows earned value at that end of second quarter. Now let us go to actual cost. Actual cost is nothing but the actual cost spent till date for the task, or project. Curve now shown on the slide represents the actual cost. Again, end of the curve represents the actual cost at the end of second quarter. Now let us talk about schedule and cost variances. The difference of earned value and plan value is the schedule variance. In this example, earned value is less than plan value. Therefore, the schedule variance shall be negative. This means that project is behind schedule. Now the question arises, how much behind the schedule is our project? There are 2 approaches to address this. First is how much amount of scope of work in the terms of cost the project is ahead or behind. Second approach is how much the project is behind, or ahead in the terms of time or duration. Let us first talk about scope of works in the terms of cost. It is simple. Schedule variance is equal to the value of scope of work the project is behind or ahead of the schedule. Note that this value is based upon budgeted cost units. We shall discuss the time approach in a moment. But before that, let us discuss cost variance. Difference of earned value and actual cost is cost variance. In this example, actual cost is less than earned value, therefore project is under budget. When we say under budget, this means that we are spending less than budgeted cost, which is favorable to the project. Now let's talk about if the project is on schedule or behind. i.e. the second approach on how much the project is behind the schedule. Let us go to the earned value at the end of second quarter on the graph. As shown on the slide, draw horizontal lines connecting to plan value curve. The point on the x-axis corresponding to the plan value shows the day or date on the project schedule on which the actual work progress at the end of second quarter, should it have been completed, as per the original schedule or plan. Therefore, the difference between two lines on the slide shows the amount of time the project is behind schedule. This approach of calculating project schedule is also called earned schedule. Now let us talk about two terminologies: budget at completion, BAC, and estimate to complete, ETC. Let us plan the remainder of the project. Extension of the actual cost curve shows the expenditure plan for remaining portion of the project. Amount of money planned to spend until the end of the project considering the current actual expenditure made is called estimate at completion. The point highlighted on the slide shows estimate at completion or EAC for the project. The question is, how we have calculated the estimate to complete. In the previous slides we discussed three ways of calculating estimate at completion. Here let us assume that we have used third method, where we have computed a new bottom-up estimate to complete for the remaining activities. We can observe from the graph that the project is showing certain delays from the original plan schedule. Let's get back to the next point of discussion of estimate to complete or ETC. Estimate to complete is nothing but the additional amount of money required to complete the remaining part of the project. Arrow on the slide shows estimate to complete for the project. As learned before, estimate to complete is the difference between estimate at completion minus actual cost. The last term is variance at completion or VAC. It is the difference between budget at completion and estimate at completion. We can observe that variance at completion is positive here. This means, at the end of the project there may be certain cost saving. In the previous part of the lecture we learned about the concept of earned value management. Now we shall learn how to implement earned value management system in an organizational setting. Here we shall discuss ANSI, EAA 748 standard briefly. Note that earned value management system and its implementation is beyond the scope of this certification. Therefore, if you're not keenly interested in earned value management system implementation, you may skip this part of the lecture. ANSI/EAA 748 defines EVMS as is a set of business practices that, when applied to a project or program, integrate scope, schedule, and cost objectives. Establish a baseline plan for accomplishment of project or program objectives. And employ earned value techniques for performance management. ANSI, EAA 748 prescribes 32 criteria for EVMS implementation in 5 categories: organization, planning, scheduling, and budgeting, accounting considerations, analysis and management reports, revisions and data maintenance. We shall discuss each category briefly in upcoming slides. Under organization of the project criterion, we must define the entire project. Establish an integrated project baseline based on a WBS. Establish management controls responsibilities within the WBS. And at last, assign responsibilities for all WBS elements. Next, we have planning, scheduling, and budgeting criterion. ANSI, EAA 748 recommend that we must employ a formal planning, scheduling, and budgeting system, and measure performance against the integrated performance baseline in the terms of cost, schedule, and scope. Accounting considerations are next focus of ANSI, EAA 748 standard. It is desired from the project account system to provide accurate and timely cost reports at the WBS element level. Record project costs as consumed or incurred. In order to achieve this, the project must be provided with an accounting system that can measure planned value, earned value, and actual cost. Analysis and management reports. The reporting system must provide regular reporting, at least monthly, on cost, schedule, and scope of the project. The project team must analyze actual performance against the authorized baseline. This analysis must include a minimum of schedule variance and cost variance. Revise forecasts of final results based on actual performance is yet another important aspect. The project team must work out estimate to complete and estimate at completion. Implement managerial actions in response to earned value information is another factor for successful EVMS implementation. Without this, no EVMS implementation benefit can be realized. Revisions and data maintenance is the last group of criterion. This require for timely approval/rejection of all change requests. Incorporate approved changes in a timely fashion. Reconcile budget changes to authorized scope changes. And control retroactive or those changes that may lead to rework. Now we come to the end of this lecture. Before we conclude, let us quickly recap what we have learned in this lecture. We started this lecture with a question: why we need earned value. We understood that traditional cost management-based project performance review methods do not comprehensively provide visibility on project performance, and that is where earned value management system or EVMS comes to help us. As we continued our lecture, we discussed key earned value terms. These are planned value, PV, actual cost, AC, earned value, EV, cost variance, CV, cost performance index, CPI, schedule variance, SV, cost performance index, SBI, estimation at completion, EAC, estimate to complete, ETC, variance at completion, VAC. In the later part of the lecture we talked about forecasting using EVM. Here we talked about 3 forecasting approaches using earned value management. We concluded this lecture with brief note on how to implement earned value management system following ANSI EAA 748. Here we noted 32 criterion prescribed by the standard under 5 categories of organization: planning, scheduling, and budgeting, accounting considerations, analysis, and management reports, and revisions and data maintenance. With this we conclude our concept lecture on earned value management. In next lecture we will take one more cost engineering and project controls concept for detailed discussion. If you wish to learn more on earned value management and how to implement an EVM system, you may refer to the following resources. Recommended Practice, RP82R13, Earned Value Management, EVM, Overview and Recommended Practices consistent with ANSI EAA 748, by AC International. Recommended Practice, RP81R13 Required Skills and Knowledge of Earned Value Management, by ACE International. With this we conclude our concept lecture on earned value management. In next lecture we will take one more cost engineering and project controls concept for detailed discussion.